Hello, Alvin ISD mathematicians. Today we're going to be looking at some examples of our standard A2C, which is writing linear equations in two variables. So really quick, this says writing linear equations. Keep in mind what that can look like is we have standard form. We also have slope-intercept form, where m represents our slope and b is our y-intercept. And then we also have point-slope form. So the generic y minus y1, which is equal to the slope, multiplied by the generic x minus x1. In point-slope form, please remember that x1 and y1 is a specific point on the graph, and then x and y we leave as our variables so that we can predict future values. So today we'll be writing those equations in one of the three forms using two variables, x and y, and we'll be given a table of values, a graph, or a verbal description. So we'll be using those three representations to write a linear equation. So our first example is writing an equation from a graph. And I notice right off the bat that all of my answer choices are in slope-intercept form, which means from this graph, I will need to identify my slope and my y-intercept. I know my y-intercept is where it crosses the y-axis, so very quickly I'm just going to identify that, and I know that the value of b will equal 4. To find my slope, I'm going to pick 2 points that are what we call clean points, meaning they go through where there are integer x and y coordinates, like where it crosses in the middle of the intersection. That's what we're going to use for our clean points. So I'm going to use my y-intercept that I've already put the point on, and I see my x-intercept, or my root, of 6. So I'm going to find the change in y and put it over the change in x. The change in y is my vertical change. So I notice I went from 0 up to 4. So I've increased by 4. So my change in y was a positive 4. Now I see that my horizontal change, or my change in x, I'm now going left. And I'm going from the value of 6 all the way to 0, meaning I'm decreasing by 6. So in my denominator of my ratio, I will put negative 6. I'm going to simplify my fraction, and I get a negative 2/3. Guys, the fact that my slope is negative when you look at our graph makes sense because our line is decreasing. When our line decreases from left to right, our slope will be negative. And when it's increasing from left to right, our slope will be positive. So now that I have all of my pieces, I have my y-intercept and I have my slope, I'm going to put them together, and I get that y is equal to negative 2/3 of x plus 4. I notice my answer choices are all in function notation, so I can easily write that g of x, which is the same as my output, is equal to negative 3x plus 4. And I see that j will be my answer choice. On our next example, now we're writing an equation from a table. And I notice my answer choices are not in slope-intercept form. So very quickly, I'm just going to go ahead and simplify them to that. So I'm going to distribute the 26. So for f, now I have y is equal to 26x minus 52. And now that it's in slope-intercept form, I can identify that my slope on f would be 26, and my y-intercept would be negative 52. When I distribute the negative 26 on answer G, we get that y is equal to negative 52x plus 26. For h, we distribute the 13 to get that y is equal to 13x minus 26. And then for j, we distribute our negative 2. So we get that y is equal to negative 52x plus 2. So now that I've simplified my answer choices into something that I can understand in slope-intercept form, where I can identify what my m is and what my b is. Remember, m is slope and b is y-intercept. I'm going to now look at my table, my representation. So m, which is slope, is the change in y over the change in x. So I'm going to use the table. I see that from 0 to 78, I've increased by 78. And then from 2 to 5, I've increased by 3. So my change in y would be 78 over my change in x, which would be 3. And I would simplify 78 over 3 to give us 26. I just want to take a moment to point out that I could have used any points on this table because they do have a constant rate of change or a slope. I chose to use 0 to 78 because it was a simple, starting from 0 to 78, I knew the change. For my y-intercept, I could work backwards in my table, or I could take a point right here and I can plug it into slope-intercept form. So slope-intercept form is y equals mx plus b. Now I know my slope now. My slope is 26. So I'll put 26 in for m. I don't know b, but I do know an x and y that's on my line. So I will plug 0 in for y, and I will plug 2 in for x, and then b remains our variable. So 0 will equal 52 plus whatever b is. So b will equal negative 52. Now that we've found all of those values that we need, again, we can put them in slope-intercept form. So y will equal 26 times x minus 52. So F is our answer choice here. This is very similar. So now we have a graph of a linear function that's on a grid or a coordinate plane. And now we're trying to match which equation is best represented. All of our answer choices right now are in point slope form. Which, remember, is y minus y1 will equal slope times x minus x1. So first I'm going to find the slope because I see right here there are 2 slope options. So I'm just going to use my graph to find what the actual slope is. Again, finding clean points. So I'm going to use the y-intercept of negative 3. And I see 7, 2. So my my vertical change went from negative 3 to 2, so I've increased by 5. My horizontal change went from 0 to 7, so I've increased by 7. So my slope, which is change in y over change in x, will be a positive 5 over a positive 7. So I can get rid of answer choices A and B. Sorry about my dog in the background. Once I have that, now I'm choosing between C and D, so I need to figure out which point is on my line and which one is not. So for this to become plus 2 and plus 7, that means that they're saying the point negative 2, negative 7 is on my line. And for this to be y minus 2, x minus 7, that point is a positive 2 and a positive 7. So when I go to graph negative 2, negative 7, That is not on my line, but positive 2, positive 7 is. So my answer choice is D. All right, guys, our last example. We have a restaurant. At a restaurant, jars of tomato sauce are stored in boxes on the pantry. Each box contains 8 jars of tomato sauce. I'm just going to draw a picture right there. So each box has 8 jars. A cook uses 2 jars from one of the boxes. So we have all these boxes, and all of them are going to have 8 jars. But this last one had 8. Our cook came in and took 2 of them. So now we're at 6. We want to know which function shows the relationship between y, the total number of jars and tomato sauce remaining in the pantry, and x, the number of boxes in the pantry. So just by looking at my visual, I can see that that rate of change, if I'm going from how many boxes I have to how many cans, each box has 8. So then to find number of cans, I can take 8 and multiply it by x, which would be the number of boxes. But I can't forget that I have this last box that only had 6 because the cook already used 2 of them. So here, my answer choice would be A, because it has that slope of 8, that rate of change of 8, and that initial value or constant of 6. All right, guys, thank you very much.